Right, today in geometry, we're looking at Envision chapter 3.2 over translations. The chapter 3 essential question, what are the properties of the four types of rigid motion? 3.2's essential question, what are the properties of a transformation? After today, you should be able to describe the properties of a figure before and after a translation. This very first thing in our notes you will be doing in class with a partner. So I'm not going to go over that here on the video because that's going to be done with a partner. So we're going to go straight down to properties of a translation. Okay. So if we're going to talk about translations, we need to know what a translation is. So a translation, this is another one of our vocabulary words. Remember, our vocabulary test is on Monday. A translation is a transformation in a plane that maps all points of a pre-image the same distance and in the same direction. The translation of triangle ABC by x units along the x-axis and by y units along the y-axis can be written as, so here's our notation, the capital T stands for translation, and then what are we translating? What's the rule? X comma y. What are we translating? So in parentheses, triangle ABC is equal to triangle A prime, B prime, C prime. So it tells me a translation has the following properties. If I look at this picture, if the translation of x comma y of triangle ABC is equal to A prime, B prime, C prime, then the line AA prime is parallel to the line BB prime, which is parallel to the line CC prime. So all of these lines, okay, from A to A prime, from B to B prime, and C to C prime, when I connect those lines, those three lines are going to be parallel. Then that line, A to A prime, is congruent to the line BB prime, which is congruent to the line CC prime. They all have the same length, okay? Triangle ABC and triangle A prime, B prime, C prime has the same orientation. So that means it has not been flipped. There's no reflections here. A translation is simply a move, okay? It moved up or down, left or right, okay? But it has not rotated any. A translation is a rigid motion, so the length and angle measure are preserved. So remember that in order to be a rigid motion, we cannot change the size. A translation does not change the size of anything because all that we're doing is shifting left or right, up or down, or both. Okay? So, next thing we want to look at, find the image of a translation. So it says, what is the graph of T, so translation of 7, negative 4, triangle EFG equals E prime, F prime, G prime. So here in the picture, they give me triangle EFG. It tells me, step number 1, that the subscript 7, negative 4 indicates that each point of triangle EFG is translated 7 units to the right and 4 units down, because X is left or right, Y is up or down. If X is positive, it goes to the right. X is negative, goes to the left. Y is positive, it goes up. Y is negative, it goes down. So first, we want to find the coordinates of the vertices of the image, and then plot the points and draw triangle E prime, F prime, and G prime. So first, let's just list what are the points of the triangle that they have listed. So point E is at negative 5, 4. Point F is at negative 1, 5. And point G is at negative 2, negative 1. Okay? So now, in order to find E prime, F prime, G prime, we just have to do this 7, negative 4. So we want to take each X and go to the right 7. It's a positive 7, so I'm going to take my E, I'm going to take the X value, negative 5, and I'm going to add 7 to it. When I do that, negative 5 plus 7 gets me 2. I'm going to do that with all of the X values. So F, I'm going to take negative 1, I'm going to add 7 to it. That gives me 6. I'm going to take G, Its x value is -2, add 7, and I'm at 5. So that I have all of the x values of my primes. Now I want to find the y values. So it says 4 units down because it was a -4. So I take all of my y values and I subtract 4. So the y value of E was 4. So 4 minus 4 puts me at 0. F, I started out at 5. 5 minus 4 is 1. G, -1 minus 4 puts me at -5. So now I can write E prime, F prime, and G prime. I can write those coordinates because these are my x's, these are my y's. So E prime is now at the point 2, 0. F prime is now at 6, 1. And G prime is at 5, -5. So now I'm going to plot these points. So 2, 0, this is E prime. 6, 1, this is F prime. 5, -5, this is G prime. And connect. So there is the translation of triangle EFG, and it was translated 7, -4. Right, so now we're going to do that without a graph. What are the vertices of triangle E prime, F prime, G prime for each translation? So the translation 6, -7 of triangle EFG equals E prime, F prime, G prime. So again, I want to take the same vertices that I had up here. So E was at -5. So -5 plus 6 gets me 1. So I'm going to find all my x values. F was at -1 plus 6 puts me at 5. G was at -2. -2 plus 6 puts me at 4. So those are all the x values of my primes. So now I want to find the y values. My y is at -7, so I'm going to subtract 7 from all my y values. So E, I started at 4, so 4 minus 7 puts me at -3. F started out at 5. 5 minus 7 puts me at -2. And G started out at -1. -1 minus 7, -7. So it turns to -1 plus 7. Sorry. It's just -1 minus 7 puts me at -8. So now my new coordinates. E prime is at 1, -3. F prime is at 5, -2. And G prime is at 4, -8. So part B, take the translation 11, 2 of triangle EFG. So again, start out with all of the x's. So E started out the x value at -5. I have a positive 11, so add 11 to that. So -5 plus 11 puts me at 6. Go to F, -1 plus 11 puts me at 10. And G, -2 plus 11 puts me at 9. So these are all of my x values. Now I want to find my y values. The y in this translation is a positive 2, so I'm going to add 2 to all of my y's. So if I go back to E, 4 plus 2 puts me at 6. F, 5 plus 2 puts me at 7. And G, -1 plus 2 puts me at 1. So my points, I have E prime, 6, 6. F prime, 10, 7, and G prime, 9, 1. So that's all there is to finding the vertices of a translation. Not too bad, right? If it's a positive number, we add it. If it's a negative number, we subtract it. So now we're going to look at writing the translation rule. So it says write a translation rule that maps STUV onto S prime, T prime, U prime, V prime. So here I'm just telling you how we're going to do that. We're going to use one pair of corresponding vertices to determine the change in horizontal and vertical directions between the pre-image to its image. I can pick any of these points, S, T, U, or V. If I pick S, okay, so S, where does it start out at? That is -5, 6, right? So -5, 6. S prime is at -6, 2. So I'm trying to figure out how did it get from S to S prime. So how did I get from a -6 to a -5? So that is my horizontal direction. Okay. So, or I can say then I start with the -6, subtract -5, I get 1. Okay. Or I could go the other direction and say if I started at -5 minus -6, again, I'm at a change of 1. So I look at, and I know from -5 to -6, it went left 1. So I went left 1. So now, change in the vertical direction, the Y. So I started with my Y, my pre-image is at 2. So if I do 2 minus 6, I'm at -4. Or if I went the other direction, 6 minus 2, I'm at 4. I have to look at the picture, okay? Or I look at the points. From 6, I started at 6, I went down to 2, so I know that I'm going down 4 units. So left 1 puts me at x minus 1. Down 4 puts me at y minus 4. So these numbers just tell me how much I moved, and then I look at the x values to determine if I went left or right, up or down. So the translation maps every xy point to my new rule. My x's go x minus 1, my y's y minus 4. So the translation rule would be written as t and then x minus 1, y minus 4. So to get from each point that I started out with in my pre-image to my new image, I'm going to go left 1, down 4. So left 1, down 4. Left 1, down 4. Left 1, down 4. Left 1, down 4. And we see that that does in fact work. Okay, so that's all there is to writing your translation rule. Next page. We're going to practice that. What translation, excuse me, what translation rule maps the point P, right, so point P right here, to its image P prime. P is at -3, 1. Its image is at 2, 3. I can either look at the map, look at the graph, and I notice that P to P prime going right and then up. So I just have to determine how much to the right and how many up. I could look at -3 to 2. So to get from a -3 to a 2, so -3 minus 2 gets me at -5. So my distance, I went right 5. Or I could count that. 1, 2, 3, 4, 5. Remember that distance is always absolute value positive, right? And then how far did I go up? From 1 to 3. So 1 minus 3 gets me at -2. The absolute value of that is 2. Then I went up 2. Or I could have gone the other direction. I could have said here from 2 minus -3 gets me 5. 3 minus 1 gets me 2. So then I'm already positive. So the translation rule, since it's the translation, capital T, okay, and then I'm going 5 and 2. So that tells me that I start at P. Since it's +5, I go right 5, +2, up 2. So now let's look at this next picture. What translation rule maps B to E? Again, look at the picture. So I see to get to B, I'm going to have to go to the left. So how many am I going to the left? So I'm going left 1, 2, 3. And then I have to go down, how many? 1, 2, 3, 4, 5. Down 5. So my translation rule, capital T, left 3. So since I went left, okay, that's a negative 3. Down, also negative, negative 5. There's my translation rule. Now, same set over here. What translation rule maps A to B? So from A to B. So I notice I'm going to the right. So right 1, 2, 3. So I go right 3. And then down 1. So my rule, capital T for translation, I went right 3, so that's positive 3, down 1, minus 1. There's my rule. So now we're going to talk about a composition of rigid motions. Remember that a rigid motion does not change length or angle measure. Length and angle measure are preserved, okay? So a composition of rigid, that should be an I there, and no D, rigid motions is a transformation with 2 or more rigid motions in which the second rigid motion is performed on the image of the first rigid motion. Okay? This is what the composition is going to look like in our notation. And here it tells you that the small open circle indicates composition. So anytime you see that small open circle, it means a composition. So this is read as the reflection, because it's a capital R, reflection about line L, the composition of that reflection, and the translation of negative 2, 5 of triangle ABC. So step number 1, okay, we start with the second one. We would translate triangle ABC left 2 units and up 5 units. After we have done that, then where we're at, we reflect triangle A prime, B prime, C prime across line L. Okay? So we're going to look at this. So compose translations. And learning a new dance, Kyle moves from position A, this is position A, to position B, and then to position C. What single transformation describes Kyle's move from position A to position C? If I just say that I'm going to let A be the point 0, 0. So to get from A to B, what would my transformation or my translation rule be? So A to B, I see I'm going over 2, up 2. So that rule would be translation 2, 2, right 2, up 2. Now to get from B to C, so from B to C, I notice that I'm going over 1, down 1. So my translation, again, I went to the right 1, so positive 1, and then I went down 1, negative 1. So if I want the composition, so my transformation of 1, negative 1, and 2, 2, it's me. If I add these together, so my translation, okay, so 1 plus 2, I went to a 3, so this was an x plus 3. My y's, I went from negative 1 to, and then a 2, so what am I doing? I'm adding 1. So the final, or the single translation is translate 3, 1. So let's see if we are in fact correct. From A to get to C, I go right 1, 2, 3, up 1. That's what's represented right there. Okay. So now we're going to do that without having a graph or anything to look at. What is the composition of the transformation written as one transformation? So I know it's going to be translation. The first one says 3, negative 2, and then 1, negative 1. So look at your x's. They're both positive. So I add them together. What's 3 plus 1? 4. So it's a 4. Then my y's, -2 and a -1. So again, I add those together. -2 plus -1 gives me -3. So it's a translation of 4, -3. So now I want the composition of this one. So again, I know it's a translation. I look at my x's. I have a -4 and a -2. Add those together. What's -4 plus -2? -6. My y's, a 0 and then a 5. Well, what's 0 plus 5? 5. So my translation is -6, 5. All right, last page. We're going to relate translations and reflections. So we're going to relate what we are learning about today with what we learned about yesterday. This should not be there. This should just say, how is a composition of reflections across parallel lines related to a translation? So now we're going to look at composition of reflections. So in this picture, notice I have triangle ABC, my pre-image. And then over here, I have A prime, B prime, C prime. That is my image. And then I have A with 2 marks. That's called A double prime, B double prime, C double prime. So step number 1, to get from A triangle ABC to A prime, B prime, C prime, it said we reflected it across the y-axis. Remember, we learned yesterday if I reflect across the y-axis, I'm folding it over this line. So what changes are my x's. So this B, the y didn't change, the x changed signs. The A, the x changed signs, the y stayed the same. C, I went from -5 to a +5. So that's how we got that. So then, to get A double prime, B double prime, and C double prime, I now take this image and I reflect it over line M, and I get A double prime, B double prime, C double prime. So it says, notice the distance between corresponding points on the y-axis and line M, okay? So how far is it from my y-axis to line M? So 1, 2, 3, 4. That's 4 units. Notice that B to B double prime, A to A double prime, and C to C double prime, it's the same amount of units, okay? Which is what? So how far is it from here to here? From here to here, and from here to here. So let's count that. So 1, 2, 3, 4, 5, 6, 7, 8. That's 8 units. Okay? So what this says is if triangle ABC is translated eight units to the right, 8 units right, its image is triangle A double prime, B double prime, C double prime. So I could write this as a transformation. So therefore, I could say the reflection about line M, the composition of that with the reflection of the y-axis of triangle ABC is equal to the translation that I get from here to here. We went right 8, so 8, 0. I didn't have to go up or down any of triangle ABC. All right, so now let's try that without a graph, right? And again, notice that I reflected up here across the line M, so same distance. So C was 1 space apart, 1 space apart. A was 1, 2, 3 units. So my other A, 1, 2, 3 units. Remember that those are always the same distance apart from what we're reflecting. Okay, so suppose N is the line with the equation y equals 1. With given triangle DEF with vertices 0, 0, E 0, 3, and F at 3, 0, what translation image is equivalent to the composition of the reflection over N, the reflection of the x-axis of triangle DEF. So first, let's look at what would be our x-axis reflection. Okay, so my x-axis, what would my D prime, E prime, and F prime be? Okay, so I know an x-axis reflection, what's happening? My x's stay the same, my y's change. So D prime is still 0, 0. E prime is 0, negative 3. F prime is 3, 0. Now I'm going to reflect on the line y equals 1. So if I'm reflecting on the line y equals 1, each of these points now, so D double prime, E double prime, and F double prime. Each of these points, right, I'm reflecting over a horizontal line, right, so I'm flipping it up, right, so the point 0, 0, right? And if that helps you, I'm just going to draw a picture of this over here. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 1. So this right here, y equals 1, this is our line that we're reflecting about. If I take the point 0, 0, okay, so D prime 0, 0, how far away is 0, 0 from the line y equals 1 that I'm reflecting? It's only 1 point away, right? So its reflection, when I flip it, is also going to be 1 point away. So if I reflected that, this is my new D double prime, which is now at the point 0, 2. Okay. If I took point E prime, 0, negative 3, so this is E prime, how far away from this line that I'm reflecting it is it? It's 1, 2, 3, 4 spaces. So I need to go 4 spaces up. 1, 2, 3, 4 spaces. Here's my E double prime. So that point is now 0, 1, 1, 2, 3, 4, 5. So 0, 5. F was at 3, 0. So this was F prime. It is how many spaces away? 1. So it's going to be 1 space away. So it is now F double prime is going to be at 3, 2. So look at the change in these, right? Did any of my x's change? 0 to 0, 0 to 0, 3 to 3. I did not have any change in x's. So my one rule translation, my x's did not move left or right any, so that's 0. Look at my y's. I went from 0 to 2. That's a change of 2. I went up 2. I went from negative 3 to 5. And from 0 to 2. Again, they moved up 2 spaces because that's how far away we were. So 2. Okay? So I had to move up 2 to get each of these. Okay? So up 2, up 2. Okay? So my translation is 0, 2, 2.